Well, welcome to another episode of Booth Ross and the Joy of Mathing, episode 12.1, because we're talking about polar coordinates. Get so excited. So, you're used to the rectangular coordinate system. We're switching over to the polar coordinate system this unit, for the most part at least. So, it actually acts much like the rectangular system. However, we have something called the polar axis right here, and then the center is the pole instead of the origin. But the polar coordinates are just another way of mapping things out. You can actually put a rectangular coordinate right on top of a polar coordinate, but instead of writing things in terms of x and y, you put things in terms of the radius and an angle. So that is the big difference. So the first thing we need to do is know how to graph on the polar coordinate system. Now, not all your graphs will necessarily have these same lines. I used the unit circle angles and put them right onto my polar coordinate. Sometimes they'll just put the axes right here that you're used to, and then don't put any of the other lines for the angles. Just be aware of that. And sometimes they won't even put the circles down. Often they do, though. So here's how it works. The 2 is your radius. 3 pi fourths is our theta. So I'm going to go to 3 pi fourths, which is right here. And then I'm going to go from the pole out to along 3 pi fourths. And done. That's it. So I'm going to do several pretty quickly. This is just a reminder that you're going to want to know your unit circle really well for this unit. Okay? So we've got 3, 7 pi 6, the same thing. This is our radius. This is our theta. I usually go to my angle first. So 7 pi 6 is right here. And I'm just going to go out 3. 1, 2, 3. And there's the coordinate. So this is our radius and theta. Remember, negative angles. So 2 pi thirds is usually right here. So negative 2 pi thirds would be where 4 pi thirds is. So you're just going backwards. And then we're going out 4. 1, 2, 3, 4. Nothing too crazy yet. No, I'm just kidding. All right. Honestly, these aren't any more crazy than the others. So 13 pi thirds, you just need to know where that is. So remember that 6 pi thirds is the same as 2 pi. So if I subtract 13 pi thirds from 6 pi thirds, I will get a 7 pi thirds, which is still not on the unit circle. So you can subtract again and you get a pi thirds. So that's right, not there. Let's try that again. That's right here. So on pi thirds, you just go out 5. Once again, nothing too crazy. You just have to convert it to something you're used to. Now, here's where it does get a little interesting when we have a negative radius. So 11 pi 6 would be this marker right here. But when you have a negative radius, you actually don't go along this this angle. You go along the angle that's exactly 180 degrees across from it. So this one right here, or pi across. So it should have the same denominator. So this is 5 pi 6. So we're actually going to go backwards from the pole along this line, and we're going to go back 3 and put a point. That's as crazy as graphing these get. So with that said, I don't know if you could tell, but there are actually an infinite number of ways you could actually write any of these coordinates. So for that reason, we're going to get creative here based on these values, and we're going to write the coordinate negative 4, 3 pi in 3 different ways, 3 additional different ways. So remember, 3 pi is coterminal with pi, so we're along this value right here. However, because it's a negative radius, we're going to go the opposite direction. So from the pole, we're not going to go along that line. We're going to go opposite. 1, 2, 3, 4. Right here. So it's helpful to first draw the point so that then we can actually name all the different coordinates depending on the information. So this right here is just saying if you see r is greater than 0, they're saying your radius needs to be positive. We're not going to change the value. We're just going to make it, we're going to change it to a positive number. That's it. In fact, I'm going to go ahead, put B. This one, if it's saying less than, tells us it's negative. So B has to be a negative 4. And then C has to be a positive 4. So here's how it works. So now we got to look at the angles that we're allowed to use. We have to have an angle that's between negative 2 pi and 0, but we're including negative 2 pi but not including 0 since those two are coterminal. So since this radius is positive, we are actually going to want to name this angle. Anytime it's positive, we're going to want to name the angle that's on the red dotted line. So, because that's where the point is. So we can't call this 0 because it's not included in our bounds right here. So it's not included right there. But instead we'll call it negative 2 pi. And that's your answer. Now, since this is negative, negative means we're going to be along the angle will be along the blue dotted line. So we got to look at our restrictions for this one. We have to be between 0 and 2 pi. That should be easy. That's just your normal, the normal values. So this would be pi right here. So we'll go ahead and call that pi. Letter C now is going to be between 2 pi and 4 pi. But once again, because the radius is positive, we're going to choose the angle that's along this positive, on the red dotted line. There we go. So we know that's 0. We know this is also 2 pi. It's also 4 pi. But we're going to choose 2 pi because that's the one that is included according to the inequality. Okay, so we'll just go ahead and say it's 4 2 pi, and there's your solution for that one. So all 4 of these will give you the same plot. They're written differently. Let's do one more of those. Little exciting one. So let's go ahead and do 3 7 pi 6. This one's easy, so we just got to go to 7 pi 6, which is right here. We're going to go out 3. And so let's go ahead. A, B, and C. A, we know R is greater than 0, so it's positive. B is less than 0, so it's a negative. And I'm going to change that as to 3's because that's the radius right here. That's a little awkward. And then this other one is also greater than 0, so we're going to use a positive 3. Maybe I should do circles. Okay. So now we got to find our angles. Now I'm going to, for the negative one, I'm going to go ahead and highlight it. So negative means it's not going to be on the same line as the dot. So it's going to be 180 degrees across. So that's going to be this one. They will share this. If we're doing radians, they'll have the same denominator, just so you know. So that's always helpful. And then the ones that have a positive radius should have an angle that's on the line I did dotted in green. Okay. So for this first example, we want our answer to be between negative 2 pi and 0. So we're looking for the negative angle. So this is positive 7 pi 6, but it's also negative 5 pi 6. And you can do that by subtracting 2 pi or however you do that. Okay. For our next one, we're going between 0 and 2 pi, so this should be the easy one. However, because the radius was negative, we want the angle that is on the orange dotted line that I made. So that is positive pi 6 right here. Sweet. And that's just pi away from 7 pi 6. It's an easy way of finding it. Okay, the last one, letter C, should be between 2 pi and 4 pi. So, and we want it on the green dotted line. So we know 7 pi 6 and negative 5 pi 6 are coterminal. If I just add 2 pi or 12/6 to this, you'll get 19 pi 6. So you're adding 12/6. Oops. If I can write 12/6, there we go, pi 6. Or you're subtracting 12 pi 6 to get these numbers. And 12/6 is just 2 pi, full rotation. So we know our last one is 19 pi over 6. And there you go, there are your solutions.